Okay, we're looking at mixed exercise 6 from the first year core textbook. So we're on circles and we're on question 23. So we've got an exam question, but it's also problem solving. So it's going to be a little bit to think about. So we are given 3 points and told they're on the circumference of a circle. And then we're asked to show that from R to T is a diameter. So as soon as we're on a sort of trickier problem solving one, most likely going to need a sketch to think about what's going on. Okay, so they've told me that RT is a diameter, so I'll draw them as though they look like a diameter, and then S is another point. So I haven't at this stage worried about drawing those in the right position. So I'm just sort of trying to get my head around what they're explaining. So how am I going to show that RT is a diameter? Because I don't know the radius of the circle. One option actually would be to come up with a full equation of the circle. If you've done question 21, you had to do that there. Well, that's how I tackled that one. So I could do that, but that was quite a lot of work. It's 4 marks. There is an easier way of doing it, and so this is why you always want to sketch. If you think back to your circle theorems from last year, if you've got the diameter and you make a triangle, so if you put a vertex somewhere on the circumference of the circle, that will be a right-angled triangle. Okay, so, and that wouldn't necessarily be obvious without sketching it out, but now if you do notice that, or you do remember that, then this is a much easier way of doing it, because they gave me those 3 coordinates. So as long as I can prove that RST is a right angle, then I've therefore proved that RT is the diameter of the circle. Okay. So, because if RT wasn't the diameter of the circle, sorry, I should just clarify. So if those were just 3 random points and RS and T were just chords, then none of those would be right angles. Okay, so if there is a right angle at S, and we've already been told that they're on the circumference, so we're not proving they're on the circumference, we know that's true. So we're just trying to show that if there's a right angle there, then it must be that RT is a diameter. Okay. Right, so that's then easy enough, isn't it? So ST, so the distance from S to T is going to be the square root of 8 minus 7 all squared plus minus 7 minus 4 all squared. So that's 1 squared plus 11 squared. This doesn't work, I'll check some of my arithmetic. So, and then RS is the square root of 7 minus 4 all squared plus 4 minus 3 all squared. So that is also square root of 122. My mind anyway. Okay, so those are the 2. So ST is that side there. RS is that side there. So those are, when we're checking if we've got a right angle or not, which we're going to do through Pythagoras, those are the 2, those are sides A and B. So T is the hypotenuse. So RT is the square root of 8 minus 4, oh, sorry, 8 minus, so let's do that again. Okay, so RT is the square root of 8 minus 4 all squared plus minus 7 minus 3 all squared. So that is 12 squared plus 10 squared, so root 244. So I think we're going to be okay. So that's RT. So checking using Pythagoras. So it should be that ST squared plus RS squared equals RT squared. Yeah, if there is a right angle at S. And I think we can see that it does, but let's just double check that. So ST squared is root 122 squared, RS squared is root 122 squared. RT squared is root 244 squared. So that is true. So therefore, our angle RST is a right angle, which means RT is a diameter. So that's from your circle theorems from last year. Okay, right. So find the equation of a circle. Okay, so that's what I didn't really want to have to do, but I think, oh, actually, no, that is a little bit nicer because I know that RT is a diameter. So yeah, that's really not so bad, is it? So we can find the midpoint of RT, and we can find the radius. Okay, so let's make a start on that. Okay, so there's my sort of circle. There's RT. Let's get these written down, then I'll move the screen up. Okay. Okay, so I want the equation of that circle. So first thing I want is the centre. The centre is going to be the midpoint of R and T. So 8 plus minus 4 over 2 for the x coordinate, and minus 7 plus 3 over 2 for the y coordinate. So 4 over 2 and minus 4 over 2. Okay, so centre of the circle is at 2 minus 2. So that's the first part of that will be the first part of the equation. And then the radius. So for the radius, now I've got the centre. I can either just do the distance from the centre to R or the centre to T, or I can do the distance between R and T and then halve it. Okay, so let's do from C to R, because that's going to be the radius. So that would be the square root of 2 minus 4 all squared plus minus 2, oops, minus 2 minus 3 all squared. So that is going to be the square root of 6 squared plus minus 5 all squared. So that is going to be root 61. But it's actually R squared I want to put there. So if R is root 61, R squared is 61. So we'll just double check that. That's what we're getting for the equation of our circle. X minus 2 all squared plus y minus 2 all squared equals 61. Awesome.